All right, here, multiple regression. So this is population model, okay? So beta 1 through beta p is a slope regression coefficients. Beta 0 is y-intercept. Here, example, we will try to understand the outcome teacher community levels, teacher community for the high school in the NELS school data set. So we used this NELS school data set for our midterm exam. We saw some error plots for this outcome. In our last set of slides, we will use more than just one predictor to try to explain teacher community. First, let's look at the histogram. Okay. So this is pretty normal, even though the mean says 0.1319, not 0. So mean is higher than 0, so which means slightly negative skewed, but this small deviation is okay. Okay. We want to just say overall trend of normality. So this is still regarded as a normal distribution, even though it is a little bit high peak here, and also mean is a little bit higher than 0. It is still regarded as a normality, okay? So here, as I said, correlation table. So 0.415 is pretty high between principal leadership and teacher influence. Yeah, it's pretty high. And 0.429, yeah, happiness and teacher influence. So the dependent variable was teacher community. So, this the relationship between teacher influence and teacher principal leadership, and the relationship between teacher happiness and teacher influence is pretty high. So we want to avoid this kind of thing. Here, look at this. Teacher anxious and teacher happiness. This is very, very high, higher than 0.5. Okay. Negative or positive, it doesn't matter. The magnitude, the absolute value, the magnitude is important. If this is too big, this means you should choose one for your model. Otherwise, multicollinearity is messing up your standard error. But how could we choose which one? Which one should we choose? Which variable is more justifiable based upon the theory? Yeah, so you have to choose it based upon the theory. You have to justify that, okay, by the researcher's judgment call, okay. Here, one variable and the other variable scatter plot, right? So linearity looks pretty linear. So how could you know this is linear? How could you know that? Here, oh, this looks linear and this looks linear. It looks flat, but how could you know this flat is also regarded as linear? How could you know that? Because as long as they are not seen as any other peculiar relationship, for example, quadratic or cubic or specific other types of, shape, then we still say it is linear, even though this is very, very low linearity is seen, still linear, okay? Almost flat, so 0, slope 0, but still linear, okay? 20, page 20, okay, so this table says just dependent variable. It's not that meaningful anyway. Predictor, this table shows a predictor. One predictor. And when you run the regression, simple regression, look at this R, 0.572. You remember correlation matrix here. Principal leadership and the teacher community outcome variable 0.572, same, because bivariate. Okay. Yeah, R, this is correlation, and this is you square it, then you will get it. And this is model summary. Okay, so it's about 30%, 32.7%. Okay, explained by principal leadership for the Y outcome. Source table shows us that the predictor is significant. Also, we can see the t-test and detailed slope coefficient result. Okay, so this ANOVA is not the same as that I was talking about in the controlled experimental design before, like using categorical variable. You know, that's a type of a model which is used in controlled experimental design. But ANOVA is still one of the regression analysis, special type of regression analysis. But here ANOVA, this is just for overall model. This is SPSS term. So don't be confused with that. Yeah. Well, anyway, so here overall model is statistically significant. Surprisingly, a lot of students didn't get the correct answer for the midterm exam, the 2 questions about interpretation of a table, hypothesis testing. Yeah, let me repeat it again. P-value, this is called P-value. And if P-value is smaller than alpha, 0.05, that is statistically significant, and we reject the null hypothesis at that time. What was the null hypothesis? This is the simple regression, right? So null hypothesis is beta principal is the same as 0. So we reject that null hypothesis. So beta principal leadership is not the same as 0. That's the result. Okay? So once you see tiny number below 0.05 in this column, then you have to say we reject the null hypothesis. So beta principal leadership is non-zero. And this is statistically significant at alpha 0.05. Okay? F. If you can find out F distribution from the internet, then you get F value based upon this 2 degree of freedom. Then you will get the critical value for the F value. And if your F value is larger than the critical value of F, then you will say, you have to say, this is statistically significant, which is consistent with this, okay? But it takes time to find out the F critical value from the internet, right? So we don't need to go through this one. You just say, oh, this p-value is smaller than alpha 0.05. That's why it is statistically significant. We reject the null hypothesis. The end. Okay? Just like that. here, t-test. Since we have only one x variable here, if you square this t, you will get this f. So t squared equals f. But it's not the same case in the multiple regression, right? So we don't do it. Only what we are going to do, square it, and then it's going to be the same as f. Is only working well in the simple regression, okay? Anyway, see this p-value. Again, since this is smaller than 0.0 alpha, 0.05 alpha level, this is statistically significant. Again, if you find out t-distribution table, you will find the t-value. Well, anyway, this method is too complicated, right? And it takes time, so you just choose this method, p-value. Regression of teacher community on 4 predictors. So now multiple regression. So you remember this R square is much larger now because we added 3 more predictors, right? Okay. Principal leadership here, and then we added this, and that, right? So this R square is, automatically increased. So, I mean, regardless of good X variable or bad X variable, as long as you add more X variable, R square is supposed to be increased. So don't trust this guy. You better choose this one when you have multiple X variables, okay? So you report this one instead of that. So most people sometimes, forget about saying adjusted, but when you see the multiple regression, then people just kind of, know, okay, that R square is adjusted R square. Yeah, we take it for granted, Do you have any questions? Yeah, so model summary in model, overall model. So the model has been improved compared to that of some simple regression, okay? So ANOVA overall model here, again, this is statistically significant. So here, F-test tells us if any of X are of use. Why does it say so? So overall model test, you have 4 X variables. As long as one among 4 is statistically significant, your F-test value, p-value is gonna be smaller than 0.05. Okay, as long as one is statistically significant, your model is gonna be statistically significant. Okay, so once you see this statistical overall model is statistically significant, then the next step is individual slope test, which is t-test. So you need to find out which X variable is statistically significant. Does it make sense? So if your F-test is not statistically significant, you don't need to go to individual slope test because you already know none of them is statistically significant, so you don't need to go to the next step. Does it make sense? What I just said is kind of important. Okay. So F-test, overall model test. And once it is statistically significant, then you move on the next test, which is individual slope test, t-test. Then find out which one is statistically significant, okay? Now we see the table of t-test and other information about the slopes. Well, actually, what I'm talking about is also learned in PAD628. That's what I heard from Dr. Kalechi. Yeah, some people might feel, oh, it's redundant, but some other people, this is new. So I wanna still cover this again, okay? All four x's are significant, yay! Okay. Also, we can compare the importance of impact of the slope. Okay, so this is unstandardized coefficient. So we don't compare the unstandardized coefficient among the x variables, okay, because principal leadership has a different unit and teacher influence different unit. Like, for example, this is weight, this is height. One use pound, one use like foot, feet. Then you don't compare two different units using these numbers, you know, different meaning. So what should we do? We have to standardize them. Then they become scale-free. So how could we do it? We just divide this unstandardized coefficient by standard deviation. Then we get this number. So every number is already divided by standard deviation. So these values are scale-free and they can be comparable. They are comparable. So which values are the biggest one? Which value is the biggest one? 0.373 is the biggest one. So therefore, principal leadership is the biggest impact on the Y teacher community outcome. Okay, so you have to have these values here. Okay, so when do we compare the magnitudes? Once you see this p-value first, you have to find out what variable is statistically significant first based on this p-value. And then once you see, let's say 3 variables are statistically significant, then you want to compare these 3 variables magnitude on the Y outcome, and then go back here. Go to this column, okay? And then if this variable is not statistically significant, don't make it participate in the comparison of magnitude, okay? Because it is not statistically significant. But here, actually, it is statistically significant. So you're gonna compare all of them. But hypothetically speaking, if this is not statistically significant, then you shouldn't use this value to compare the magnitudes with the others, okay? So number one, you want to compare this, you want to see whether or not the variable is statistically significant based on this p-value, okay? They are all smaller than 0.05 alpha level. And then everything is statistically significant. And then you want to see which one is highest magnitude on the Y outcome. Then you go to this column, standardized coefficient. Then, oh, principal leadership is the highest one. Second one is, oh, teacher happiness. Third one is teacher influence. And the smallest, the least impact variable is teacher anxious. Is this anxious? Or anyway. So, you know what to do, right? Number one, number two, okay? Before, what did you do? ANOVA overall, if you see this is statistically significant, and then you go to the second step, t-test table. If your overall test is not statistically significant, then you don't need to go to the t-test table, right? Then once you come to the second stage t-test table, then first of all, you see these p-values, and then next step, you want to compare the magnitudes of the variables. Then among the statistically significant variables, then you compare the standardized coefficient, the magnitudes. This is called the beta weight. Beta weight. Do you remember that? All right. Let's return to the correlation matrix. We now know that teacher anxious and teacher happy are highly negatively interrelated. Yeah, multicollinearity. So you want to remove one from the other. I mean, you have to choose one between two. This may mean we do not need both in the model. This occurs because multiple regression gives us the partial slopes for the x. The effect of each x controlling for the others. We will talk more about this next week. For now, let's see what happens if we drop out teacher happiness. I am only showing the slope table, where now the teacher anxious slope is again negative. So teacher happiness and the teacher anxious may be collinear. There is much more to do with this model. We need to click some buttons in SPSS to get the SPS output. We need to check residuals, look for homogeneity of variance. Yes, we did that in the midterm exam. We will see 3 more plots obtained from the plot button. These include the residual plots. We need to evaluate our assumptions about the residuals. Yes, residual assumption checking is really, really important, right? And I gave you exam cheat sheet, so practice with that for SPSS program. They are histogram for normality, residual assumption, homogeneity, and y versus predicted values, linearity, so y and y hat, linearity, regression of teacher community on 4 predictors. We use the histogram to check for normality of residual. To me, this looks pretty normal, and mean is kind of negative number, but it's still small, too tiny number. So we regard this as normal. Okay, this has a kind of peculiar pattern. So, well, okay to me. It's still, homogeneous to me, but some people might they might have some concern about that. Yeah, depending on what area you are in. Yeah. Anyway, the conclusion itself doesn't matter. I mean, the way how you justify your claim is more important, okay? So I read your interpretation all the time, so give me more clue when you put your answers or questions or claims, okay? So, all right. Whenever you have questions, please email me, okay? Okay, bye-bye.